still in chapter 7 here, talking about momentum. This involves an elastic collision for question number 6. Now, I put a couple formulas up here on the board that says these two formulas are only valid when one of the objects in an elastic collision is initially at rest. So if we want to find the final velocity of either object when either object 1 or object 2 was at rest, we can go ahead and utilize these formulas. Otherwise, we have to go back to our conservation of momentum equation, m1v1 initial plus m2v2 initial equals m1v1 final plus m2v2 final. So question 6 says, a ping pong ball of mass 2 grams traveling with a velocity of 2 meters per second collides with a stationary tennis ball that has a mass of 10 grams. So I just drew the tennis ball to be bigger, and these two, ping pong ball and tennis ball, end up crashing into each other. And the tennis ball is stationary, so it is initially traveling at a speed of 0 meters per second. Calculate the velocity of the ping pong ball after the collision, assuming the collision is elastic. So it tells you in the problem you're looking at an elastic collision, and we know that we have one object, the tennis ball, which is at rest. So if we want to find the final velocity of the ping pong ball, we can go ahead and use the first formula, which says V1F, which is the ping pong ball, is equal to the mass of ball 1 minus the mass of ball 2 divided by the mass of ball 1 plus the mass of ball 2 times the initial velocity for ball 1. The big thing when using these questions, they are both multiplied by the initial velocity of the first ball. And it cannot be the second ball because they are at rest and the whole quantity would be 0. So you have to make sure you're multiplying by the term that has the greatest velocity, or the velocity that is not 0. So let's go ahead and do this. So the ping pong ball is 0.02 kilograms minus 0.10 kilograms divided by 0.02 kilograms plus 0.10 kilograms, and we're going to go ahead and multiply it by 2 meters per second because that was the initial velocity for ball 1, and we get a velocity of negative 1.33 meters per second. Once again, your answer choices only show positive numbers. The reason why this question in particular is negative, if a smaller ball hits a larger ball, it is going to bounce off in the opposite direction it came from, therefore it's going to have a negative velocity. So if initially the ping pong ball was traveling to the right, in the final direction it's going to bounce off and go to the left, and you'll have a negative velocity of 1.33 meters per second, or a speed of 1.33 meters per second, which is answer choice number 1.